Good afternoon, everyone. So, before I say anything about Module 5, just want to say I've posted the key for Module 3. I've also updated the grades and posted those on Canvas. So now you should have 3 modules that have been graded unless you turned in an assignment late, in which case, again, that will be marked at the discretion of your TA, and I'll update those marks as they come. But so if you want to keep track of how you're doing, just make sure to look for the Module X final score. So I set it on Canvas so that the final scores, which are the sum of the quiz and the assessment, will calculate your final score, and all the other ones are set to not have any weight. So you'll see multiple things listed in there. Anyway, so the grades have been updated. And again, for Module 3 and all the subsequent modules, I stopped putting the right answers in the fill-in-the-blank questions. I got tons and tons of emails about it. But the point is that I did that because since I have to remark it anyway, I'd rather just see what the organic spread of answers is rather than having people try 10, 15 different combinations to get my exact wording. I don't want you to just try and get the answer by process of elimination. So anyway, I posted the answers, and so you can see here, like for the numeric answers, I've got what you get, the range for the correct answer. So I put the correct answer and then the range that I accepted, and then the range I accepted for half credit. For most of the numeric questions, folks did pretty well, and it wasn't an issue. For QA 13, some folks did lose a point. So Canvas messed up and accepted 2 answers, even though this question type is not supposed to have 2 answers. So it marked anyone who put strong as correct. I think there were maybe 18 folks who did that, but the answer is moderate. And so I provided the values where the R-squared matches up. So anything below 0.3 is no correlation. 0.3 to 0.5 is, well, anything below 0.3 would be very weak, which is essentially none. 0.3 to 0.5 is weak. 0.5 to 0.7 is moderate. And so the R-squared value is 0.64, meaning it's a moderate correlation, not a strong correlation. Strong is anything above 0.7. Don't think there was anything else that tripped up too many folks to talk about there. But one thing I will say for all the written answers, they were marked following this rubric. For the file submission, it gave you a bit more detail. And so this is more or less the guideline that your TAs followed marking that question. So if anyone has any specific questions about the key or whatever, feel free to just shoot me an email and ask me a question. Now, for Module 5 this week and next week, because it's a 2-week-long module, what we're going to be doing is learning about spatial overlay methods. So spatial overlay methods are kind of like the central crux of what we do with GIS, right? So we've gone over different types of data, different classification methods, ways we visualize data. Spatial analysis is when we take disparate layers, multiple different pieces of information, we overlay them on top of each other to generate new information and do something called spatial inferencing, or drawing conclusions from spatial data. So for the lecture content for this module, there's no lecture content for today specifically. The lab is fairly long, and so anytime you would spend watching the video content for today, you can just spend on the lab. And so I will go over spatial overlay and spatial inference methods on this coming Wednesday and on next Monday. And then I would like to point out on next Wednesday, so that's November 3rd, we're going to have a guest speaker come in to class. A friend of mine, Alicia Barata, works for an organization called Peace Geeks, and so she's a working GIS professional, and she's going to talk a bit about what she does, how she applies GIS in her work, and I think this will be a unique opportunity for you all to see like how you can actually apply GIS and what you can do with a geography degree having studied GIS. So next Wednesday, November 3rd, Alicia's going to come in. I'll give maybe 10, 15 minutes of lecture at the beginning of class, and then Alicia will spend the last 30 minutes of class talking about her work. So for lab this week, what we are doing is we're going to actually do a real GIS analysis. So this is something that a GIS professional would do if they're working in hazards planning, for instance. So what we're going to do, excuse me, what we're going to do is conduct a tsunami risk assessment for the community of Port Alberni. And so similar to last week, I've already set up a project for you. You can go ahead and download it, and so get working with it from there. And the main things that we're going to need to do are to identify areas at risk based on elevation and distance from coast. And then we're going to overlay some vector layers of interest, population, properties, roads, and proposed shelter locations on that risk layer that we create. And then we're going to visualize and analyze those results. And so similar to Module 4, most of the instructions are video-based, especially with this lab being that it's a little bit more complicated. I think the video-based instructions makes things a little bit easier to follow. So first, you're going to read through this section where I frame the problem, just explain a bit about the context behind it. And there are also 2 short readings associated with this lab. So you can find links to them here. You only need to read the highlighted portions of the 2 files. So it's only 1 or 2 pages each. But this sets up the context behind why we are concerned with what we're doing. Specifically, Port Alberni has a very unique geography. Port Alberni is way at the head of this inlet, and being so far up this fjord, which is essentially a funnel, it really magnifies or amplifies the size of a tsunami wave that comes up. So if a tsunami wave comes up this inlet, as it's funneled through the Port Alberni inlet, it actually increases the wave height. And so tsunamis that impact Port Alberni are especially powerful. And so it's a big issue. But anyway, so for lab, you're going to watch these videos. You're going to work with the project that I've created, and then I provide you with a little bit of data from the city of Port Alberni. You're going to once again get some data from Simply Analytics. And you're also going to get some data from a site called DataBC. This is a site that you can use to get a wide variety of data sets for the province of BC specifically. So we're going to use it to get roads layers, but this could be quite useful for folks when it comes time to do your final projects. And I'll introduce that 2 weeks from now. And so the big kind of step up here from previous weeks is in addition to doing some geospatial, more intensive geospatial analysis, we're going to be using something called Model Builder. And so Model Builder is a tool in ArcGIS Pro that you can use to set up workflows. Basically, you string together tasks. So this is the model that I've provided you with already in Inundation Zone. You're going to create your own new model that's going to look like this. But what Model Builder does is it allows you to string together tasks to analyze information. And so we're going to use Model Builder to set up a process. That way it's repeatable and we can do lots of different things with it. Our scenario here, or our end goal, essentially, is you're kind of pretending you're working as an analyst. And you're working for the city of Port Alberni. They want to assess the potential impacts of an 8.5 magnitude earthquake occurring directly off the coast of Vancouver Island. And so we're going to look at what could be the potential impacts of a 10-meter high tsunami hitting the community of Port Alberni. So specifically, what we are going to need to do is try to find what roads are at risk for flooding or damage, which properties are at risk for flooding or damage, how many people in Port Alberni are potentially living in areas at risk, and also, given a set of potential tsunami shelters, are the capacities of the shelters sufficient and the locations of the shelters safe? So you're going to use all the steps in lab to answer these 4 questions. And then at the end, you're going to write a brief little synopsis, just kind of basically answering those 4 questions, describing the steps we went through to get the final result. It doesn't have to be a pages and pages detailed report or anything like that. I don't want it to be too stressful, but the point is to summarize the analysis and summarize the results